So complex numbers has to be one of my favorite topics, and this is chapter 16 of the textbook. So we're going to look at different parts of complex numbers today. Very quickly, we're going to go through the complex number I, our most basic complex number. We're going to look at what are the real and imaginary parts of a complex number. We're also going to look at the geometry of a complex number. So how do we plot these? We're also going to look at two more things, what it means if two complex numbers are equal, and how you add and subtract complex numbers. So I is the most basic complex number, and we say that I squared equals -1. If I know that I squared is -1, then if I take the square root, I'll get I is equal to the square root of -1. So because this is the most fundamental or the most basic complex number, we try and write other types of complex numbers with the form of something I. So let's have a look. I cubed. I can write I cubed as I times I times I. Or I could write this as I times I in a bracket times I. So I squared times I. This is great because I know what I squared is. That's -1 from the statement above. And so I have written I cubed as -1 times I, or just minus I. We do the same for something like I to the power of 4. So try and write it in terms of I squareds and I's and then simplify. I to the power of 4 is really I squared times I squared, or I squared or squared. That sounds really weird. Okay, I squared is -1, sub it in, then square it. Well, I know -1 all squared is just 1. So those two are the same. I to the power of 4 is really just 1. 10I to the 6, again, we want to write the I6 in terms of I squareds and I's. So you can either write this as 10 times I squared times I squared times I squared and substitute I squared equals -1 into that expression, or I can write it as 10 times I squared all to the power of 3. Again, I squared is -1, cubed -1, that should still be -1. So I'll get 10 times -1 or -10. For the last example, it's a little bit different, but the same process applies. First, let's multiply our real numbers together, or our coefficients. Then we'll multiply the I parts together. So I'll have 3 times -2. That's all times by, well, I have I to the power of 4 times I to the power of 3. I know that 3 times -2 is -6. And I can write I4 times I3 as I7 using our index laws as usual. Again, I've got to think about how I can write this I. Now, I can actually write I to the power of 7 as I6 times I. I know what I to the power of 6 is from the previous question. We said I to the power of 6 is -1 cubed, or -1. So everywhere I see an I6 in my expression, I'm going to sub in -1. The -6 times the -1 will just become a +6, and I'll still have the I hanging off the end. So it simplifies quite nicely. Now, I is not the only complex number. We can add things to the I, and we can multiply it by things as we've seen before. So we can actually write any complex number as having two parts, a real part and an imaginary part. So we can say z is a complex number and it looks like x plus I y, where x and y are real numbers. So we could have a complex number that looks something like 7 plus 3i. The real part of the complex number is always the x part, or simply the constant real number. In the example that I just put, the real part would be 7. We also say the imaginary part of a complex number is the coefficient of I. It does not include I, it is just the coefficient. So the imaginary part we say is the y component. In the example that I just wrote down, it would be positive 3. So take the sign with it. Okay, 4 examples. What are the real and imaginary parts of the following complex numbers? For A, we have that z equals minus I. Now I'm just going to rewrite this so it looks like something x plus iy. So I could really write this as it has 0 minus 1i. So if you have minus I, that's just the same as put a little 1 in front of it. And then we can clearly see the real part is just 0. I don't have a real part in this number because it's all about the i's here. And I can easily now see what my y part is also. So the imaginary part would just be the coefficient of the I, which is negative 1. We do exactly the same thing for the next 3 examples. Make sure they're in the form z equals x plus iy, and then we can identify the real part. So for B, 2 plus I, the real part is just going to be that constant 2. And the imaginary part is going to be my coefficient of the I, which is really just a positive 1. You can always put the 1 in if that helps you. For C, this is nice. It's already in the form that I like. 2 minus I. So the real part, again, just the constant, which would be 2. And the imaginary part, again, is the coefficient, similar to before, except this time I have negative 1. For D, I have a problem. It's not really of the form some number plus something times I. So I'm going to rewrite it again in the form that looks like that. 7 can be written as 7 plus, well, no imaginary parts, so plus 0i. This way I can easily identify the real part of z, well, that's just the 7, and the imaginary part of z is 0. Voila! And we've identified the real and imaginary parts of complex numbers. The last thing we're going to do in this particular video is the geometry of complex numbers. So complex numbers can be sketched on a complex plane or an Argand diagram. The real part goes along my horizontal axis and my imaginary part goes along the vertical axis that is normally corresponding to my usual y-axis. So where you have this imaginary number p, I notice it's 3 along the real and 2 up the imaginary axis. So we can write it as 3, the real part, plus 2i. We're going to sketch 4 numbers here. Z equals minus I. So recall we can write that as z equals 0 minus I. All you have to do now is identify the real, the imaginary part, and put it on the axis. So I have no real part, so I'm going to start at that origin 0. But I do have a -1 imaginary part, so I'm going to go down 1 on my vertical axis, or my imaginary axis. That's your point A. For B, we have 2 plus I equals Z. This means I'm going to go 2 in the positive direction of my real axis, and I'm going to go up 1 on my imaginary axis. I put the point in, so this is the imaginary number or the complex number, 2 plus I, and I'm going to call it B. For C, we have the complex number 2 minus I. This is going to look similar to B in the fact that I'm going to go 2 across my real axis, but I'm going to go 1 down on my vertical axis or my imaginary axis. Put the point in, and then finally we have Z equals 7. So again, I'm going to rewrite this as 7 plus 0I to see my imaginary and complex parts. Notice it only has a real part, so I go across 7, but I don't go up or down any numbers. So that's my last point, and I'll call it D, right on the real axis. We're going to come back to the second half in a second video.